In this video, I'm going to show you how to use Stamp. I'm going to show you both how to run the tool and also how to browse the output that the tool produces and how to use that to find interesting security behaviors in Android applications. In particular, we're going to be looking at source sync flows. So I'm going to begin here by opening up a terminal, and this is just in the virtual machine that you already have. And we'll be looking here in the home directory at a bunch of directories, and the stuff that we're interested in is in the lowercase stamp directory. So if we go in there, we'll see first of all this green thing is actually a script, and that is the tool itself. That is the stamp tool. So that's the script that you invoke to run stamp. And in the apps directory, there is a tutorial subdirectory. All right, and then there are two small tutorials, and there are write-ups on these in the documentation. And for this video, I'm just going to take a look at the lesson 0 tutorial. All right. Now, in order to invoke Stamp, it's very easy. You change into the directory with the code you want to analyze, and here we can see that this is a directory with some additional subdirectories. Okay, so the code itself is actually in the subdirectories, but this is the root of the directory subtree where the code we want to analyze sits, and we just cd into that directory, and then we invoke the script, which is the one I pointed out a few directories ago, and we give it the option analyze. So you just say stamp analyze and hit enter, and away it goes. Okay. Now the first time you run this, it's going to run for a very long time because it's going to build the entire system. And here I've already built the system, so this will not run for nearly as long, but still it invokes quite a few tools, and there's a fairly lengthy chain of programs that get run here to produce the eventual information. Now what's going to happen when it terminates is that it's going to pop up a browser in which we can look at the results, and there it is. Now we probably didn't see it, or maybe you noticed it just before the browser popped up, but it said the build was successful. If the build is unsuccessful, or if the browser crashes for some reason when you're browsing the results, it's always okay to just go back and run the tool again in exactly the same way. So in particular, if you're browsing the results and you hit some kind of problem, the Apache server crashes or something like that, you can just rerun Stamp, get the results back, and then browse around in them. All right. Okay, so let's take a look at the analysis results. We could also look at the classes if we wanted to, but for this tutorial, we're going to look at the analysis results. And now there's a bunch of different analyses that Stamp produces. Since we're particularly here going to look at a source sync flow, we want to look at the source to return arg flows here. That's what this is called. All right, this is the piece that we're interested in. So we click on that, and we're going to get a little menu down here, which is structured on the base, just like the code, and it's going to show us as we open up these directories where there are places, where there are sources that have interesting flows. Okay, so there turns out there are two sources here, get location and get device ID. And let's take a look at the get device ID one. All right, so if we click on that, now we'll see what we mean by a source. So here's a method, all right, and in general the way this works is that the pink line here is the one that corresponds to whatever you clicked on over in the left-hand pane. So when you click on something over here in the left-hand pane and it pulls up a piece of code, it will highlight the line that was being discussed or was being pointed to by the left-hand side. All right, now so in this case we're looking at this call to get device ID. Okay, actually not this definition of get device ID. All right, and this is a model that we have added to the code. So get device ID is something that's kind of a primitive in Android and didn't have any code associated with it. So we have added this to the system, and we've also added this annotation up here. All right, and so this is a Stamp annotation, and it says that get device ID has a flow to its return value. All right, so this is where flow starts. So get device ID is a primitive. It reads the device ID and returns it, and so this is a piece of private data, sensitive data that we want to track. We want to know where it flows in the program. All right. So now, and here we can see that this call to the string constructor is highlighted in a kind of reddish pink. All right, that indicates tainted data. So whenever something is highlighted like in this color, that's a place in the program where sensitive information flows. The result of that expression is sensitive information. All right, now we'll say I have to tell you that there are some limitations currently on our ability to highlight all of the places where there's sensitive information. There's some that don't get highlighted. So and that's going to be improved in the future, but there are some limitations in that. We'll actually see that in this tutorial, that not everything that's tainted gets the highlighting, although the tool underneath does know that those things are tainted. All right, so sometimes you have to look around, and you may find things. You may have to look around to make sure you see everything that's tainted, because the highlighting is not 100% reliable yet. Okay, now what can we do from here? Well, the tutorial that's in the documentation suggests one way of browsing the results. I'll show you a different way here. So what I can do is I can say, I can look at device ID, and you see there's this little menu here. This little arrow indicates that there are some options here. This is a function, so things that are highlighted in blue are function calls or function definitions. And I have two options here on Get Device ID. First, I could edit the model. Okay, so what does that mean? Well, I can provide information about things like library functions to say what they do with sensitive data. If they take sensitive data in, do they return it as a result? Do they update one of their parameters to hold it? Do they do nothing with it? And there's a little menu here which I think is fairly self-explanatory that can tell you, it gives you some options based on the signature of the method, and allows you to construct information or construct a model for how this method affects information flow. Now, we've already done it for this method, so there's nothing to do. We don't want to change the model that's already there. This annotation is already there, and we lost the position, so I have to click on that to get back. Okay, and so we're not going to edit the model here, but you can supply models of your own for APIs that we haven't gotten around to writing models for yet. And in general, the view in the stamp is that the auditor, the person using the tool, is going to have to write some models for new kinds of primitive functions or library functions that the tool can't possibly have information about. All right, now the other thing we can do, since we already have the information that this returns sensitive data, is we can look at where it's called in the program. So we can show the callers. Let me get on that. Okay. And we see there's one caller in this little example. All right, so we go to the caller, and we click on the caller, and now we see, again, here's the line, okay, highlighted in pink. And we can see that this is the call to get device ID, and it returns a tainted value, device ID. So then we're interested in where this device ID gets used, and here we can see that it's used down here. All right, and here's a place where the highlighting isn't working yet. Okay, so this device ID here is also tainted, of course, since it's the same variable there. But now we should probably look at what happens inside of execute with its argument, since that's going to be tainted. So we can show the targets. Okay, for a method call, you can see the targets of the method, and we'll see there's one place where this method is executed, or sorry, one place, of course, where this method is defined. All right, and if we click on that, okay, here's the line we're interested in. So the execute takes an argument called params, and if I scroll a little bit right here, you can see the lowercase name params. And now we want to see where params is used. Again, here, this isn't highlighted, but it is tainted. And so now we're going to look at do in background. Okay, so we want to see the targets of do in background. All right, and that's this method here. So we click on that, and now we're looking here at do in background. Okay, and what we see is that the parameters come in. Okay, we read something out of the parameters, which taints the message variable. All right, and then the message variable is used in a call here to concat, which produces another tainted string. All right, and then we construct an HTTP GET request, okay, which is also tainted, and that's finally passed to client.execute. And if we look at client.execute, if we go and click on that, all right, and then we look at the code for execute, what happens? We see, aha, that request actually goes to the internet. So there's a flow from the argument request out to the internet. And this bang notation here indicates a sink. So that's a place where information leaves the system and goes out to an untrusted sink. So a dollar sign in front of a flow value indicates a source, and an exclamation point indicates a sink. All right? And so that we have found a source sink flow here of trusted or sensitive information flowing to an untrusted destination.